Our first keynote speaker is Cindy. Cindy is from IBM, of course. Cindy is a technical visionary driven by wanting to make a difference around the world, advancing health, safety, and well-being of others. She believes that data security and privacy are key enablers realizing the benefits of digital and consecutive enterprises. Cindy has worked with hundreds of clients across the multiple industries, including finance, healthcare, and public sector. Cindy is an active member of International Association of Privacy Professionals, IAPP, and she is a certified information privacy manager and certified information privacy technologist and co-author of governance principles and practices of big data landscape. Cindy invented the IBM's GDPR framework and is leading IBM's security GDPR solution strategy across the company. She is a highly regarded speaker and has presented at RSA, IAPP, IBM, and Interconnect conferences. Cindy was also recently granted a patent on mobile caller risk. Without further delay, Cindy, welcome.
Good morning, everybody. I am so delighted to be here. And I'm so delighted to talk about this topic. Why is that? Because I have been working in analytics for longer than I want to remember, since the day of the dinosaur. And it's really interesting to see how AI has evolved and you know, where it's come to in terms of its benefit to cybersecurity. So this morning, what I'm going to share with you all is how AI is changing the cybersecurity and the cyber threat landscape. And I almost wish we would just rename it Augmented Insights, because it's really about assisting us in improving the way that we detect, identify, and even mitigate threats. So without further ado, let's get started. But first, it's time for us to shift gears, and let's take a moment, every one of you, let's swap out and put our notions to rest about what AI really is. So whatever you think you know about AI, let's suspend that, put it in suspended animation, because I think our perceptions of AI are so colored and affect the way we perceive it. What I'd like to do is share with you the point of view that I have about what AI is and what it isn't in terms of cybersecurity, how we can use it for our benefit today, no matter where we are in our cyber journey, but then also how are the bad guys using AI against us. That's the part that's a little geeky, and it's also a little scary. So please, again, you know, have an open mind, and that's really what I'd like to share with you today. Now, interestingly enough, AI was first invented back in 1956. So it's been with us a very long time, first learning how to play checkers at Dartmouth. By the mid-'80s, we had expert systems that were being created to help with decision making, and yes, I do remember them and did a little bit of work back then. But what's now different is we're applying them to security in new ways, and we have to if we're going to survive. So there we are, time to shift our notion. So, you know, the gentleman on the left, this is kind of the old days of security where, you know, you don't have to worry too much, you go riding around. But frankly, you know, today we're in mountain roads. It's rough territory. I don't know about you, I don't think I'd be racing. I like to sit in the back of the Harley and just kind of kick back a little bit. I'm protected, I have the right gear on. So let's think about how do we make that shift, and, you know, what is AI going to bring to the table for us. So first I'm going to talk about why AI. You know, why are threats so hard? So I'm going to talk about, you know, why is AI in security now, and why do we consider it to be what we call a force multiplier and a necessity for cybersecurity? And we're also going to separate some of the fact from the fiction, a little bit of you know, the marketing that you hear, because frankly, if you go to a show like an RSA, AI is everywhere, everybody has AI. Well, what does that mean? And I challenge each and every one of you to ask the vendor what they mean by that. Don't let them just give you buzzwords. Oh, we have AI in our tool. What does that mean? So we're going to unpack a little bit about what that does mean. And so we'll talk about how AI can meet up with security. And as I mentioned, adversarial AI, some of the frontiers of what's going on with AI attacking AI. And then where next? What are the lessons learned? What can you take away from this today, again, in your own journey? So the first reason for AI is there's an app for that. Our consumers, our constituents, they expect easier access to vital services, whatever those are. Benefits, fixing a pothole that's causing a safety issue, DMV, and for a teenager who wants to know if they passed the test, that is a vital service, right? I don't know if you have a teenager like I do. They expect these things. Digital natives expect easy access to services. So with that, data sharing is a foundation for digital transformation, and security is a critical enabler. You can no longer just get away with not thinking about how you're securing applications, and even more so, how are you securing your AI applications? And data is also no longer behind data center walls. It could be out on the cloud, and digital government requires that data to be widely shared. But we also need to strike a balance between security, privacy, and ease of access. But here's the problem. The problem is the approaches that we've been using, they don't scale. They don't scale. How many of you have security analysts who spend their days seeing an alert and then running searches through logs and using log tools to find stuff? That approach is no longer going to scale, and frankly, it doesn't serve us anymore, so we need to be thinking about different approaches. So that's the first reason for AI. The second is advanced and not so advanced threats are taking over. And so why is that? Well, first of all, we have fuzzy vision. We have lack of visibility. Most systems, security, intelligence, security event monitoring systems don't necessarily see or present that full picture of your security posture. So we're missing that line of sight in between your systems, whether that's on-premise or in adding new cloud applications. How are you gaining full visibility to know when an attacker comes in on an IP address, what they're doing as they traverse your network? Or what about someone inside your four walls? Someone who decides to make extra money crypto mining in their spare time, running crypto miners on your servers so that they can make extra money. How do you know that activity? How do you see that activity going on? So we don't have that big picture view of the threat landscape, and we lack our visibility into insider activity. Next is disconnected dots. So this is where it gets even harder. So assuming you have the right data, how are you doing your analysis and investigation? You have either a deluge of data, or maybe you don't have enough data. You don't have the right data. You don't have the right logs. Maybe you've got tons of alerts and false positives, making it real difficult to find what those threats. So we need to help discern what's a real threat, what's white noise, and then discover who's attacking those targets. What's the severity? What to triage and when, in what order? This is where security analysts are just flat out overwhelmed. Then the third is that tools talk, but they can't act. So there's a manual response. So first we figure out we have a threat. We understand after investigation the nature of that threat, how many endpoints or servers have been affected. But then, what are we going to do about it? If you rely on manual response, then we're only as slow as the slowest link. So if I have to report a breach, or I have to report an incident, if legal has to get involved, or privacy, or our physical security, what are those timings? Who knows what to do and when? So you need to be able to have that integration, a holistic view of what is going on, and then be able to act swiftly. So all of this is motivating a rush to AI. It's the AI land rush, right? We have not enough skills, we have tools that are more difficult to use, we need more insight, and then we have less and less and less time. There's that ticking time clock. Attacks spread very quickly. Ransomware attacks especially. If you don't have the insight to notice high I/O levels on your file systems because that ransomware is busy writing files, then you don't have enough time to figure out how to stop that and block that activity. So these are all challenges we're all facing, no matter where we are, no matter what industry or even what agency we work for. Yet within all this gloom, there is some hope, and there are valid reasons here today to take advantage of AI, because AI is here today in cybersecurity. So now what I'm going to do is discuss how do you get there, and examples of how AI is being used in cybersecurity and some of the ways that you can take advantage of it. So we think of it as a three-step approach. First, you have to be able to clearly visualize and have the right information. No matter what AI you use, if you don't have the right information for it to operate on, you're not going to get anything of value. So that's the first misunderstanding in AI, is you have to have clearly curated or gathered information. Now, in this particular AI case, I'm talking about analyzing threats. There are other AI use cases where you need very little information to make an impact. And a good example of that is in application security, using AI to weed out false positives so that you get to the root cause very quickly. But I'm talking about understanding a threat landscape and identifying a threat. So first you have to be able to clearly visualize. And that foundation is what we like to call an immune system. An immune system is just like the physical body, where the brain and the central nervous system is able to detect threats to the body. Whether I cut myself, I scrape my knee, I get a cold, the body's immune system knows how to dispatch and protect against a threat. So we think of effective security as an immune system where we have the intelligence and analytics and orchestration at the center, and then all the security disciplines interact with that, whether that is data security, like a DLP, so data loss prevention, maybe it's mobile security, cloud security, endpoint, application security. All those elements need to work together, and especially the user security. Who is accessing my systems? What are they doing on those systems? And this is an area that a lot of organizations are still very much maturing. They're still trying to figure out, beyond this perimeter approach, how do I understand what the real activity is? So that's first, is clearly visualizing that. And that is really rationalizing the tools you have today. Looking at the tools that you have today and figuring out which ones work for you. When we talk to clients, the average client has 80 tools by 40 different vendors, and they use a handful of them. So imagine if you went to the doctor and you got sick, and you were taking 80 prescriptions from 40 different doctors. Do you think you'd be standing here? Probably not. So the idea is, take a look at what you have, whoever's tools they are, and figure out what you have, how do they interact with each other, and what do you need? What do you need to build that foundation? Next is, once you have that foundation, is intelligently uncover. This is where advanced technologies like AI can help you understand the threats that you face. So that could be identifying the suspicious activity, using machine learning, using advanced rules engines so that you can focus on the real threats and stop chasing ghosts. Because a lot of analysts spend all their time chasing down threats. They don't really understand them. What are they doing? They're using Google. That's probably the best investigative search engine, right? I want to Google a hash, or I want to Google a specific error that's coming in. I want to Google the name of an executable. That's really what a lot of our clients are doing. So when you apply AI, then you can take the next step, which is strategically stop threats. And what I mean by that is, stop the right things and don't prevent your business from going forward. So now let's take a look at what that means and what are some of the categories of AI in security. And we think of three main categories. The first is predictive analytics. And predictive analytics model behavior and apply patterns. This is table stakes. This is what pretty much every vendor is doing or has been doing. And certainly we've been doing this for quite a few years in various aspects of our offerings. So the idea is, let's say you have a database administrator, and her name is Janet. And Janet works in, let's say, a hospital, and she checks in patients. But now all of a sudden she's very busy working at 2 in the morning, and her IP address is outside the US, but she's not on vacation. And she seems to be taking a lot of data and sending it off of the network. So to me, that sounds like pattern analysis, right? Looking at her normal behavior and then this new behavior, that's an example of predictive analytics. That would typically flag Janet as a potential bad user, someone who may be impersonating another user, and that example is what we call user behavior analytics. So UBA, user behavior analytics, is built into a lot of tools, or there are tools that do that. And that is one example of AI. So looking at patterns, clustering activity, clustering behavior, and flagging what is unusual, maybe even applying a risk scoring. That's another way that you can use AI. And we see this in network analytics, we see this in endpoint, we see this in application and data, if I see unusual spikes in activity, and we certainly see that in the cloud. Next, intelligence consolidation. This is where we are curating intelligence and doing contextual reasoning. This is the exciting stuff. And this is really, if you've heard about Watson, this is a lot of the work that we've been engaged with Watson. And it is taking vast varieties and volumes of unstructured data and making sense out of that. So what do I mean by that? That could be training the engine to read research papers and to understand the language of cybersecurity. Example, gatos. Gatos means cats in Spanish. So that's one context. Los Gatos is a town down the street. And then we have Gato Barbieri, who's a jazz musician. So if I am digesting language, how do I know what that context is? That is the process of training. That is the thing that is pretty challenging to do, and it takes time. So being able to take all kinds of unstructured content, research papers, blogs, threat intelligence feeds, even alerts that we get from managing security services for clients, we use all of that to create this corpus or body of knowledge. That is what we mean by intelligence consolidation. So what happens then? Suppose you get a threat. You can then ask this advisor, what do you think of this threat? And the advisor will come back and give you more information, perhaps identify what kind of a threat it is. Maybe it's a poison ivy virus. Maybe it is a Locky virus. So then the third is trusted advisors and response. And this is an area that's really the next turn of the crank, the next generation, and also what we're working on now. Not only understanding a threat, augmenting it with intelligence, but then advising the security analyst on what to do, what threats to mitigate first, or even what patches to apply first. That is really, these last two areas, I think, are the most exciting. So let's look at an example. When we do augmented intelligence, there are several things we do. So first, let's say we get an alert from a security event monitoring system, and we see suspicious activity. So we figure out immediately what's the target system, maybe what's the motive, the objective, how long has it been going on. That's kind of the basic information. But then the advisor would automate the AI tasks that are necessary to enrich those incidents. So for example, it might be consulted to look at what is that malware? Who is patient 0? What's the name of that malware, the family, where is it from, what locations, what delivery method, and what is the impact? That is what we mean by curating the content and analyzing that information. And it's by drawing those conclusions and linking that information together. Then last, we identify what are the compromised hosts? Where are they? What are the vulnerabilities? What's the objective? What's the attack chain or attack sequence? And the scope. So that's really this process of enriching an event by understanding the context around it, how it happened and where it happened, and then what to do about it. So in our case, we trained Watson in the language of cybersecurity. And what we did is we curated the content on the cloud. So what used to be in AI was you'd get a room full of servers and you'd spend all your time training the model. Well, what we realized is clients don't have the time to do that. And that's really where the industry is evolving, that you have this curated advisor, and then on your desktop, you have an app that can consult with the advisor. So what you see here is on the left side of the screen, this is what an attack looks like. And you can see in yellow, that little circle in the middle, that's patient 0. And what the cognitive advisor, or the AI advisor, does is it figures out all those connections by digesting all the alerts, all the activity information. And what it comes back with is it takes what is already known and it tells you which new events have been identified, which new endpoints have been identified, what's the malware family, what are the files that have been affected, and then what does it think that that family is. In this case, it's Locky, so it's the Locky campaign. And in this case, what you have is a collapsing of the amount of time it takes to do analysis. Normally, this kind of analysis will take a good analyst several hours or more, because how do you know which endpoints have been compromised? It could be virtually hundreds. So that is really the power, that force multiplier of taking what is already known and then doing further analysis and coming back and telling the analyst where it thinks it has a problem. So before I go on to adversarial AI, I think that the real benefit of using AI in context, meaning it's baked into the processes that you use, is taking something that can typically last for hours, which is doing all that research, and collapsing it down to minutes. So being able to do that very, very fast so that your analysts have more time to concentrate on the real threats. So now I'm going to talk about adversarial AI, and this is all about what bad actors are doing with AI, and it's something that you need to consider. So as you're working with stakeholders in your organization who are bringing in AI, who are bringing in analytics, they need to be aware that attackers are attacking AI with AI now. They're figuring out how to game AI models for benefit. And that, can be pretty frightening if you think about it. So let's talk about some examples of adversarial AI. Now, this is where we get a little geeky, and I will bring it back down to earth as we conclude, but this is some pretty interesting research. So there's 3 ways that attackers use AI. First is AI-powered attacks. CAPTCHA, everybody knows CAPTCHA. That's where you type in the letters, or you pick out something, the images that look like a bus or storefront, and I can't ever seem to get them right for some reason. Some of them are a little bit difficult. But there's a CAPTCHA cracker called XEvil, and XEvil has been trained on 8,500 CAPTCHA implementations, and it uses visual AI to recognize pictures and solve the puzzle. So that's a very good example of an AI-powered attack, is automating that. Next is generating targeted phishing attacks on Twitter. So Zero Fox researchers did this back at Black Hat 2 years ago. So the idea is to mine tweets, to mine someone's social media presence, to generate tweets that target exactly them. I happened to get spearphished yesterday. I had a LinkedIn friend request, and this individual claimed to be the head of security at Apple. And now I was like, oh, wow, that's cool. I'd like to connect with him. And then I read down his profile, and he was also ambassador to China most recently. And then he ran, Department of Defense cybersecurity. I mean, it was more and more unbelievable. And then when I looked up his name, I realized that he was a known Bitcoin miner and a known attacker. And if you scroll down, you saw the name of the company that he had recently worked for and been terminated from. It was a gaming company. So Attackers are probably using AI to mine my profile on LinkedIn and, figure out how to create a targeted profile. And by the way, several of my coworkers got the same request. So they're obviously, going down the list. So next is password crackers. So there are lots of neural network-powered password crackers that think in human terms about how to create a password. The next is attacking AI models. Now, this is where it gets very interesting. Some of you may remember Microsoft Tay, the chat bot, and Microsoft put this chat bot out on the internet so you can interact with it and ask it questions. Well, a bunch of folks very quickly realized how to train Tay to say very nasty things, and after 24 hours, they had to take Tay offline because attackers were training the model, it was training Tay to behave very badly. We inadvertently learned this as well when we were training Watson for Jeopardy. We fed Watson all kinds of content, from, every record album, dictionaries, encyclopedias. Well, someone decided to feed Watson the Urban Dictionary. Watson started cursing. It was not good. We had to untrain Watson. So, that's a way of attacking an AI model, is giving it bad content. Also, evasion. Researchers have demonstrated real-world attacks on computer vision with messing with facial recognition and biometrics. So in this case, when you look at pattern recognition for images, it's based on the pixels and patterns. So a researcher was able to create these glasses, the guy in the middle, and he confused the model into thinking that he was Mila Jovovich, the actress. So you can certainly game AI models and even defeat biometrics. The last category, I think, is equally chilling, and although humorous, and that is stealing the machine learning models. And you can do this in several ways. One is if there are publicly accessible APIs, you can run the model enough times that you're going to figure out how the model works, and you can either steal the intellectual property or figure out how to defeat the model. Let's say you have a risk scoring app that uses AI to figure out whether or not to give somebody benefits, and someone can figure out how to game that model so they can give everybody, all their friends, benefits and commit fraud. That's a good example. Another one is in the area of privacy, and that is figuring out what is the training data and being able to pull the training data out. So there are AI models using data extraction methods that can figure this out. And then last is making fake photographs so that you can trick the AI model into thinking that you are someone else, and that is the strange, weird image on the left there. So how do we protect against AI attacks? There's really three ways. One is data security. You have to be able to curate trusted content, so feed your AI models with trusted content, and then protect that training data to prevent against poisoning. Next is model security, and that is constructing models that are resilient by design and inserting what we call disturbance into the model to obfuscate the model. And this is where a lot of academic research is currently being done. So, and I'll get to that in a moment before I wrap up. And last is operation security. So making sure you have methods to implement access management against your models and monitor against misuse. So that's to make sure that someone isn't constantly churning through a model to try and figure out how it works and then how to trick the model. So now we get to the almost last part of the program, which is the super geek part of this, which is what we're doing in IBM research, and we call it robust AI. So robust AI is basically taking all these models that really a data scientist can generate, and most of us can't even figure out what they are, and putting them in a toolbox. So we created an adversarial robustness toolbox, and we announced it at RSA. The link is down there, and this is really a toolbox where you can test some of these techniques to defend your classifiers and defend your machine learning models. And there's several libraries that give you examples and also help you test your model accuracy. So that's a little homework. And here's an example of one way to defeat a model. It's called adversarial noise. And on the left, we have an eagle. This is a classifier AI technique using what's called VGG. So we have an eagle, and we have 99% confidence that it is an eagle. And what an attacker can do is it can obfuscate or add adversarial noise and purposely introduce noise to the model to break the model. So all of a sudden, this eagle is no longer an eagle, it's recognized as a kite. So, that is a problem. So what you can do with adversarial AI is you can put in front of the model a defense mechanism so that that same attempt at obfuscating will still remain an eagle, but it'll be with a lower confidence level. So that eagle now will be, a little less confident it's an eagle, but it retains the veracity of what the model is meant to do. So with that, I have 1 minute, 2 minutes left. I want to wrap up and talk about and share with you some lessons learned. So first of all, AI means a lot of things. It means a lot of things to a lot of people. So when someone says AI, I immediately ask them, what do you mean by this? Is this clustering? Is it analytics? Is it pattern discovery? Is it guided intelligence? So context is really key here, and it's king, but content is first. So make sure that if you are doing AI yourself, that you're curating on the right content, or that when you're working with a vendor, you get some help, because frankly, there is no magic big data lake that's going to solve all your security problems. It just is going to make it easier for you to search through your logs and comb for information. Your AI is only as good as your AI models, and that typically means having a data scientist on staff who really understands those algorithms that I shared with you a couple minutes ago. AI is also not a panacea for good security practices, and that is the foundation of everything we do, and you can't get to effective AI unless you have implemented some of your basic security practices. So the best way to take advantage of AI is to think big, start small, and act iteratively, and look for embedded AI where the heavy lifting has already been done for you, whether that is user behavior risk scoring, prioritizing which vulnerabilities you're going to patch first, or advising you on what endpoints have been affected if you're searching for a particular threat that you think has hit your systems. And if you do decide to jump into the very deep end of the pool, get help from experts. There are a lot of great vendors out there who are doing some very interesting work in AI, and there are tremendous gains in applying AI to security. And really the gist of it is taking threat identification from hours down to minutes, and then being able to respond in a fast way with guided advice. But again, you have to do your homework. And so I challenge you to explore AI, ask questions, be an avid student, and then share your progress. So with that, I thank you, and go forth and learn some more about AI.